The various types of loops that we've used iterate over collections of some sort of items. Now, it's often useful in your own code to create collections of items, and the simplest type and the most commonly used is called an array. An array is just a sequential list of some sort of data items. You declare an array as var, then you can have the variable name for the array followed by colon, then the keyword array, and then between square brackets you put a range. Remember, a range is specified with a lower index and an upper index and two dots between. Then then the data type. So, for example, an array containing 4 items might be declared as var sarray colon array square bracket 1.4 close square bracket of string, and that's 4 string items. Or you could index from 0. You could have array 0.3 of string, and that's also an array of 4 items. Let's look at some actual code examples. So you can load up the arrays project. Here you'll see I've indeed declared an array of string, and it contains 4 strings. I've declared the array up here, and then I've initialized the array between the begin and end keywords of the procedure. So to initialize an array, I need to get an array index. So this line says at the first index of array, that's at index 1, assign the value 1, that's the string 1. At index 2, assign 2 at index 3, and so on. And then my for loop, to display those in the memo, it just iterates through the array from 1 to 4 and adds the item at each array index. You can see this in action, compile it, and it's the first button, the array of strings, and it just prints 1, 2, 3, 4. As I said, I could also put 0-based array. This is also an array of 4 items, but now I need to make the indexes match. The reason I'm showing this is that it's quite common in programming to index from 0 upwards, and indeed when we've accessed lines in the memo in previous projects, you'll remember that I needed to index from 0 because that's the way that memos index their lines. And I also need to alter the for loop to deal with the 0-based array. Now I've done that, and once again I get the same results. So let's return that to the original and do all my changes. Okay. So let's have a look at some other examples of using array indexing. Here I've got a function called change case. I send to it a string. Now I index into the string. Now this is an interesting thing to bear in mind, that a string can be treated as an array of characters. So in order to change the case of all the characters in the string, I index into the string for 1 to length of string, and the string is indexed from 1, not from 0. And at each point I examine the character, and if it's a lowercase then I change it to uppercase, and if it's uppercase I change it to lowercase. Now here's another example of an array. In the earlier example I had to declare an array first and then initialize it by putting strings into each slot of the array. Sometimes it's useful to do that all in one line so that you initialize the array at the same time you declare it, and that's what I've done down here. One thing to bear in mind here though is I've declared it as constant. Now constants normally mean that they cannot be changed. A constant must stay the same throughout the execution of the program. So for example, if you look at this has been declared up here as a constant, and I've assigned it a string. I cannot change that. If I try to do so, and I try to compile the program, I get an error. I'm not allowed to change a constant. But when I initialize an array as a constant, I can indeed change it. Let me try that. I can do... Let me get to the index at 2. Now I run it. Click this button, and you can see that the array has indeed been changed, even though it's been declared as constant. Now, constants that are initialized in this way are not really constants. It's a curiosity of Pascal syntax that that's the way they're declared. And this is explained in more depth in the ebook that comes with this course, so be sure to read that for a deeper understanding of how constants and initialized or typed constants are used in Pascal. Let's return again to the problem of displaying an ASCII table. This is the project called x19. And you can see in this case I've displayed certain descriptive names alongside character codes which are normally non-printable characters. So things like null, backspace, tab, line feed, carriage return and escape. And I've used some arrays in order to help me do this. Let's look at the code. So when the form is created, this procedure runs. And all this does is it counts through the codes that I'm interested in from 0 to 255, and it then calls non-printing char, which is a function I've written up here, to determine whether this particular code corresponds to one of the characters that I'm interested in. So let's have a look at that. So this receives the code that's sent to it, anything from 0 to 255, as the ASCII value parameter. It then sets up a repeat loop and it counts through the indexes of numarray. Numarray is an array set up here from 1 to 7 of integer. So this has been initialized with the codes I'm interested in, with a certain non-printing character codes. Things like 32, which is space, or 0, which is null. If the item at that index of numarray, say for example it's 32, so say ASCII value has been sent as 32. So if the ASCII value is found in numarray, then I look in the string array, str array, at the same index to return the string. So let's say I've gone through this numarray, I found 32, which matches ASCII value. That's the code that was sent to it. I then look at the same index, so that's at index 7, in this second array, and I find space. Now you've also seen array notation in other places. I've already mentioned that we've used the same sort of square bracket indexing when looking for lines in a memo. But what about this format function? I've used this format function a few times to insert strings or integers into a string. Now, format is a special function, and notice its second argument is described as an array. And this indeed is what it is. Here I've got an array with 2 elements. The first element happens to be an integer, the second element happens to be a string. And when the format function runs, it goes through that array and it replaces the markers in its string with the elements from that array. So this is just one more example of where you see arrays used quite often in your Pascal code.